This is problem 19 of chapter 19 of Giancoli 6th edition. So what we want to know first is trying to understand this circuit. What would happen to the voltage across each resistor when the switch S is closed? So the switch S is here. You see, it's initially open, so there is no current passing through that resistance 2. We want to know now, if I close, what will happen to the voltage on each one of these resistors, R1, R2, R3, and R4. Okay, so R2, R3, and R4 are in parallel. Now, the more resistances we put in parallel, the smaller the equivalent resistance will be. Okay, so when we add, so let's put a summary here. When we add R2, which is in parallel with R3 and R4, so we know the equivalent resistance decreases. Now, the equivalent resistance for the whole circuit decreases. So if the equivalent resistance for the whole circuit decreases, we know that we are going to draw more current for the battery. So the total current from the battery increases. All right, very good. So this is important. And now let's see. If there is more current leaving the battery and going through that whole circuit, what can we say for sure? Well, this current has to go through the resistance 1, so we know that V1 increases. All right. How about the voltage in R2? Well, there was nothing in R2 before, and now there will be some current going through. So for sure, the potential difference in R2 also increases from 0 to something. All right, now let's see what is the story. We have here that the whole potential difference from the battery is equal to the potential difference for the resistance 1, so right, is this potential difference here, plus the potential difference for the whole parallel circuit, plus the potential difference for this whole parallel circle, so plus the potential difference for this whole group here. Okay, we just saw that this V1 increased. The battery does not change. This one does not change. Now this is the fixed value given by the battery. From all this, we can conclude that the potential difference for that parallel part of the circuit has to decrease, which means V3 and V4 have to decrease. Okay, so in summary, what we have first is, in terms of voltage, V1 and V2 increase, while V3 and V4 decrease. Okay, so this is for the voltage. How about the current? Well, we just said that the current increases going through R1, right? So I1, the current increases. Well, through R2, we know it also increases because there was nothing before. So the current going through R2 also increases. How about the current going through R3 and R4? Let's think now. The potential difference decreased. If the potential difference decreased, well, I know that the current will be given by this equation. So the potential difference decreased. The resistance didn't change, so I3 will also have to decrease, and I4 will also have to decrease. Okay. All right, so we concluded that the current in I1 and I2 increase, the current in I3 and I4 decrease. Comes one more qualitative question. What happens to the power output of the battery when the switch is closed? Well, this is question C, right? So the power output from the battery is just V from the battery and the total current. We just learned that the total current has to increase, right? The total current increases because the total resistance decrease. Since we have more resistance in parallel, the equivalent resistance decrease, so the total current increase. The battery does not change. Well, from here we conclude that the power output increased. Okay, so now that we anticipated everything that happened, we can go and confirm all this using real numbers. So now they give us the resistances and the potential difference of the battery. Okay, so what we know is all the resistances are equal, and each person should have a different value here. In my case, here is 125 ohms, and the potential difference from the battery is 22 volts. Okay, so how are we going to find the current through each resistance before closing the switch and then after closing the switch? Well, we have to find the equivalent resistance before and after. Okay, so let's start with before. So before, we just have to find the equivalent resistance for that parallel piece, which just involves R3 and R4. With this, we can find the total equivalent resistance for the circuit, which will be R1 plus whatever we found here. Okay, so if you go through all this, you will find that the value is 187.5 ohms. Alright, with that we can find the total current using the potential difference from the battery and this equivalent resistance. Okay, this total current has to be the current that goes through R1, right? And through R2 we know there is no current. Okay, so this is also the current that goes through I1. Through I2 there is no current. And then we can also try to find the current that goes through I3 and I4. How do we do that? Well, we have to find out the potential difference for that for R3 and R4, right? We have to find the potential difference here. Okay, so what do we have? The total potential difference from the battery, which we know is 22 volts, is equal to V1 plus the potential difference in parallel. This potential difference from the battery we know from V1 we can find is just R1 multiplied by I1. Once we have this potential difference for the parallel circuit, then we can find the current going through resistance 3 and resistance 4. How do we find that? Using this expression. This potential difference is R3 I3. This potential difference is R4 I4. You don't need to do both because we know the resistances are the same, right? So from here we can just find the two. Once you find from one, you know what the other should be. You could also just divide this one by 2, right, since you know it will split equally. Okay, now we go for the next part. The next part will follow the same idea. Now, what we do after closing the switch follows the same idea. The only thing that you now have to take into account is that the parallel resistance will involve also R2. And that's it. Everything else follows very similar.